So, hello everyone. My name is Nicholas. I work on the Google Chrome Speed Metrics team. And today I wanted to talk to you about the responsiveness metric that we have been working on. And I also wanted to gather some of your thoughts on this new metric. So the talk will be divided as follows. First, I will introduce first input delay for those who are not very familiar with this metric. And I will introduce it in the context of the core web vitals, which is important for the purpose of the talk. And then I will show a diagram that the Chrome Speed Metrics team did to try to highlight what first input delay captures and what we truly want to capture from the new metric that we are trying to design. And once I'm done with that presentation, I will present some topics that I would love to discuss with you all. And then we can start doing some brainstorming of ideas and potential approaches to solve this problem. Also, feel free at any point during the talk, if you have any questions, then feel free to raise your hand or just unmute yourself and ask the question. So let me start by showing you a diagram that was presented in a Google search post recently. This shows Core Web Vitals as being part of the search signals for page experience. So what this means is that the metrics that the Chrome Speed Metrics team designed in collaboration with the Web Performance Working Group are going to be used in the future as search signals for page experience. Of course, these metrics are user experience metrics, but they don't capture everything that Google search wants. So as a caveat, they're just a tiny signal in the whole scheme of things. But the point I wanted to make is that there are currently 3 metrics being used. One is largest contentful paint, then the other one is first input delay, and then the other one is cumulative layout shift. For the purpose of this talk, we want to talk about the interactivity / responsiveness metric, which currently is first input delay. So first input delay is a performance metric, and that metric is going to be used in search for page experience. So what is, first of all, what is the first input as defined by the metric? The first input is the first among a key down, a pointer down, which is followed by pointer up, a mouse down, or a click. So for the second one, which seems a little bizarre, why is it pointer down only followed by pointer up? Think of things like scrolls or drags. We don't want to include those. We want to include taps. So that's why we define it this way. So we basically think of it as the first key event or the first tap or whatever kind of click the user attempts on the page. And now, what is the first input delay? We define it as a delta between 2 timestamps related to the event. The first one is ironically called timestamp, the event timestamp of the user interaction. So when does the user press the button on the keyboard, or when does the user tap on the page? That is the timestamp. Think of it as the initial point in time of the interaction. And now the second point in time is the processing start. When does the renderer process start to run event handlers, assuming there are? So basically, when does the renderer process begin to process this input? Note that it's important to know that it's when it begins to process it, not when it finishes running. So in processing start, none of the event handlers have run yet. So to summarize, the first input delay is the difference between processing start and timestamp. So the time it takes from the user interaction until the render process begins to process the event. Now that we've defined first input delay, oh, I have a video. I don't know if, can you see the video? I've played it, but not sure if. So in the video, you can basically see that, I'll play it again. The user taps, but the main thread is busy for a long, long time. It's a very long task. And of course, the main thread can only respond to the input once it's no longer busy, because it was running such a long task that cannot be split into chunks. It can only handle the input afterwards. So first input delay captures this kind of bad experiences where the input is not even processed in time. Sorry. Now, what about the rest of the processing pipeline? So as I mentioned, first input delay does not capture event handler running times. So if you have a lot of work in the event handler, that is irrelevant for first input delay. So when first input delay is fast, that does not imply that your input is handled smoothly. I view it as first input delay must be small in order for your input to have a chance of being handled smoothly, but not the other way around, right? In other words, a small fade does not imply that the input is run smoothly. So this is kind of the problem we're trying to solve, is trying to capture a larger chunk of what the event handling work is, so that we can measure first, come up with a better responsiveness metric in terms of the amount of work that is covered and in terms of the user pain that we see in the web. Other thing that is not covered by first input delay is actual screen update after the event handlers run. So for example, suppose that your event handlers change the DOM in some way, like add some text to some part of the page. None of that is covered by first input delay. That would be covered if we looked at the first paint after the event handlers run. But even worse, there can be event handlers that run a lot of asynchronous work. For example, consider an event handler that runs a fetch event because it just needs to fetch some content after the user decided to click on something. Such fetch will not be resolved by the time that the event handler task is done, because the fetch API is asynchronous, and of course it requires network requests and such. There are also cases where you could think of a scheduler framework which decides to run some of the events asynchronously, and obviously those cases won't be covered by just looking at the event handlers themselves. For example, say you do a set timeout 0 inside the event handler and then run all of the work inside of that set timeout. Then the task of the event handler itself will not cover the work. So this diagram, like I said, I don't take credit for it. It was created by Chrome Speed Metrics team, but it shows kind of what we call the full duration of the event processing. So it starts when the user clicks, that is the input timestamp from user hardware. And then throughout the timeline, we see some of the tasks that are running in the main thread of the renderer. And so there may be some blocking tasks that run before the renderer actually begins processing the input. So you can see those tasks in purple. And the input delay will be the amount of time between the first time, the timestamp, and the green tasks. The green tasks are the tasks where the event handlers are run. So that is basically the click event or the pointer up event or whatnot. So those tasks are basically just event handlers. That's the green part. And then once those event handlers are run, there is a next frame presented on screen. This is the very first chance that we have of having any DOM updates in the screen based on the fact that the user created the input. But like I said, since some work is asynchronous, it may not cover everything. So this is covered by the red tasks. The red tasks are work that is kicked off by the event handler. So I should note that this would be determined heuristically. So there is no infallible way to determine from the green tasks which are the red tasks. And in fact, we don't necessarily want to cover explicitly all of the tasks that are tracked on the event handlers. Because, for example, if you're running an animation and you just do set timeout 1 second inside the event handler to, for some reason, to finish the animation in 1 second, then you don't want to cover that time, right? So the heuristic needs to be somewhat clever. And then those red tasks determined by the heuristic accomplish some DOM updates as well. And then you can see at the very right, the final frame presented on screen, which is what we think of intuitively as the final frame presented on screen. So does that more or less make sense to people? Right. So one problem with first input delay is that we cannot naively extend it to all input delay. The problem here is that the quantity of the events considered is not the same for key down versus for taps. So for a key down, you only have key down, whereas for taps, you could be mouse down, pointer down, or click. So a naive extension of first input delay to all input delay would just consider taps to be 3 times as important as key downs. So one thing to explore with the responsiveness brainstorm is what is a good way to aggregate inputs across the page in a way that makes sense. So for example, we can consider tap ups, which will be mouse up, pointer up, and click events in a single user interaction. And then we can define a metric that is based on that user interaction. So now I'm basically done with the presentation, but there are basically 2 topics that I would be interested in hearing from you. First, which interactions should we consider for the ones that are beyond the first interaction? So one obvious candidate is taps. So for taps, should we consider pointer down and pointer up to be the same interaction, or should we consider tap down and tap up separately, or should we only consider tap up? Because tap up is usually the more important interaction. But some sites do have some updates on tap down. Key down, there's not a lot to debate about key down, I suppose. But what about scrolling delay? This was mentioned in the previous smoothness brainstorm, if you were there. Should the initial scroll update be considered as part of the interactions we look at or not? And beyond those interactions, what are some common interactions from the users that generally cause meaningful DOM updates that we should be considering? So that is the first question. And the next question is, how do we generically define an endpoint to cover larger chunk of the end-to-end latency? So right now, we only look at input delay, which is from timestamp to render begins processing the event. We could just extend it to include event handler runtimes. But like I said, that's not necessarily sufficient, since event handlers could schedule asynchronous work. So one example, what about promises that are queued in the event handlers? Would it make sense to await for all those promises, in some sense, to await for them and then say, once those promises are fulfilled, then we can consider the event to be completed? Or, for example, could we use a heuristic like LCP? What is the next new DOM content that is painted after the input? Look at that content. What's the largest of those? And then that is the time when the input is considered responded to. That's the end of my presentation. But before I let other people speak, I also want to say if you have any ideas that come up, like say tomorrow you're showering and you're like, oh, I came up with this great idea. You can feel free to email speedmetricsdev. The email's in the slides. And yeah, I'm curious to hear what others have to say about any of these topics. I see a question about, do I have plans to support the frame timing API? So that is related to the smoothness discussion that just happened in the previous session. So I would follow up with them, since that discussion is very tightly related to that API. If you missed it, then no worries. The talks are being recorded. So, any other thoughts?
In terms of whether we consider things like pointer down and pointer up to be the same or different interactions, I think that the most common case for a tap involves the user puts their finger down. Say you're tapping a link. The user puts their finger down. We turn on the active pseudo style. There's some response to the pointer going down, and then the user releases, and then we actually follow the link. I think it would be valuable to independently capture the initial response to the pointer down as well as the response to the pointer up.
Just to make sure I understand, the problem could occur, let's say the user puts their finger down for a variable amount of time, like 50 milliseconds, and then the finger goes up. We're counting the finger down time when it really isn't Chrome or the site's problem. Is that the concern?
I think that's one concern with grouping them, and then the other concern is just that you do have two separate page responses. The page responds both to pointer down, and then it separately responds to pointer up.
Right. I guess the question would be, how common is it for the pointer down response to be a meaningful DOM update to the page? So
I think it can be meaningful in some scenarios or some page types. So a drawing app, it would be super meaningful where, and typically clicking on a link, it wouldn't. So yeah, but even in the clicking on the link scenario, there's the right click, which, can be meaningfully responded to with the context menu or whatnot. So
that's fair.
Nicholas, on the topic of overlapping delays when you go from first to all input delay, presumably we have the timestamps, so we'll know when things are overlapped, and you could remove sort of triple counting. However, there's the case of sometimes a delay from one of the handlers is actually the processing time of another one. And so you have this weird case of you want to ignore certain types of time, but not others. And so I wonder in general if it's important to solve this problem. Like as we move towards end-to-end responsiveness, is the only thing that's important is like the duration to the relevant frame. Maybe we can get rid of all of these cases of tracking delay, or is it still important to sort of annotate where the time went?
Right. So I think one of the things that would be good to keep in mind is actionability from web developers. So if we can provide as much of the breakdown of how much work was spent as possible, that would be ideal. So from that perspective, if we can provide, this is how much the event handlers took, this started from here to here, then I think that might be better. But yeah, I'm not super familiar if it's possible for the paint from like pointer, for like pointer up paint to be before event handlers for click. I'm not sure.
One
So.
especially gnarly case there is where we've got the tap delay. So we're on a mobile page that doesn't have a mobile viewport. And so when you tap, the pointer up is fired a good, is it 250 milliseconds or something like that? Maybe just 100 milliseconds before we dispatch the click event. And so you could have different stuff drawn there.
Yeah, so I definitely think just tracking it from the browser side should be the goal here, since the browser will definitely be able to tell that the click comes from the same pointer up and mouse up yeah. So this is part of what I proposed. I had a discussion about this at TPAC, and I proposed having some interaction ID, which the browser would expose to the developer so that they can deduplicate these pointer ups, mouse ups, clicks, which sometimes all of them are slow, so they all are surfaced by the current responsiveness web performance API, which is event timing. Does that make sense? Any other thoughts?
I think that the heuristically tracking tasks or tasks triggered as a result of the event in an asynchronous way, I think it can be extremely interesting from to make the reporting actually useful, because I think there are a lot of events out there that queue async work and then terminate early, and tracking that work would give developers actionable feedback. Do you have a sense of how hard it would be to implement those heuristics?
I don't have a clear sense, and I think it might strongly depend on what type of heuristic we're going to be using. At the same time, so part of the reason I mentioned the core web vitals at the beginning is to give some context on the fact that we don't want to be surfacing basically heuristics. We don't want heuristics that go too far into the other side, where, like I mentioned, like a set timeout that just doesn't make any sense to include it in the end-to-end latency. So I do worry about those kinds of potential problems where the heuristic could become a bit of a problem from that perspective, but maybe I'm wrong. And yeah, the performance of implementing this is definitely, I think, another concern, since the idea is to expose this data to web developers in real users, not just in the lab.
So with my scheduling hat on, tracking tasks posted by a task is easy. Figuring out whether this task was actually important or not is quite hard, because set timeout can be at the same time used to render something user visible, as well as recording some metrics that are on background priority. And distinguishing between these two cases requires, I think, extremely complex heuristics.
Doing this perfectly is definitely impossible. One specific case we can't handle is there's a JavaScript land scheduler, and your event handler just adds something to a queue in your JavaScript land scheduler, and then something in that scheduler pulls that task off the queue and runs it. There's no way we can actually track that in a performant way. So we're never going to do a perfect job here. Maybe we could get by with some heuristics that were not perfect. It's a tough problem.
Fortunately, we just have task posting API coming right up.
Definitely need to keep that one in mind for the heuristics. Although, of course, we want something that also works for existing content. So it couldn't be just looking at that one, but that could certainly help maybe in some cases.
Nicholas, there's a question in chat. Vadim Petrov asks, may it be better to measure LCP from user's tap, not from navigation start?
Right. So when I mentioned looking at the LCP after the user interaction, that would be the end time, and then the start time to compute like a delta for like how fast did you respond to the user. The start time would be the timestamp for the user interaction. That is correct. So that's how we would compute based on a LCP-ish heuristic. Largest content after input would start on the timestamp. Yes.
A somewhat related question, which I'm not sure if this is what was meant there, is for the existing LCP metric, we use navigation start, which is a little bit arbitrary. You can imagine our LCP metric instead measuring from when the user tapped that triggered the navigation, which I think is strictly more correlated with user experience, although it's harder to attribute to a single URL. We did play around a little bit with expanding our metrics back in time to the actual input that triggered the navigation, but it's a little bit difficult to do in general. There's a lot of different ways that navigations can be triggered.
Yeah. Fortunately, we don't have to deal with, well, yeah, for now at least, we don't have to deal with the navigation problem, since we're basically looking at just the user interaction as the start time. So, but yeah, for LCP, it's navigation start, which is close to when the user said it wanted to see content, but not quite the same. Yeah. All right. Any other final thoughts before I stop the recording? Okay. Well, thanks everyone for joining, and like I said, feel free to email. There's the email near the slides, and look forward to keep the conversation going.